The meaning of discriminant. Not all quadratic equations have two distinct roots. Some quadratic equations may have a single root. For example, the quadratic equation, we have the following shown on screen, has a single root, because the left part represents the expanded form of the first special algebraic identity. We have the following shown on screen. Therefore, we can write our equation as, we have the following shown on screen. It is obvious that this equation has a single root, x equals -2, as only for this value of the variable x the equation is true. Moreover, there are some quadratic equations that have no solution in the set of real numbers. We will see towards the end of this course that these quadratic equations are solved in the set of complex numbers. We can identify which of the previous types a quadratic equation belongs to by looking at the part of the quadratic formula inside the square root. This is because when the expression inside the root is positive, we obtain two different values after calculating the root and therefore, two different solutions for the equation. On the other hand, if the expression inside the square root is 0, we obtain two equal solutions, as the root is 0. Last, if the root is negative, we cannot continue with the solution as we cannot calculate the square root of a negative number. From all discussed above, it is clear that the expression inside the root makes the distinction between various cases of quadratic equations in regard to the number of roots has. We call this part of the solution as discriminant, alpha. Thus, we have the following shown on screen. Thus, summarizing the above findings, we can say that, 1, if alpha is greater than 0, b squared minus 4, c is greater than 0, then the corresponding quadratic equation has two distinct roots. Solutions, we have the following shown on screen. i.e., we have the following shown on screen. And we have the following shown on screen. Or we have the following shown on screen. 2. If alpha equals 0, b squared minus 4, c equals 0, then the corresponding quadratic equation has a single root, more precisely, two equal roots. Or solutions, we have the following shown on screen. This is because minus square root of alpha equals plus square root of alpha equals 0. 3. If alpha is less than 0, b squared minus 4, c is less than 0, then the corresponding quadratic equation has a no roots, no solutions. This is because it is impossible to calculate the square root of a negative number. Example 1. Find the number of roots in the quadratic equations in the following without making the calculations. A. X squared plus 3x plus 8 is equal to 0. B. 5, x squared minus x minus 4 is equal to 0. C. X squared minus 10x plus 25 is equal to 0. Solution 1. We have just to check the sign of the discriminant in order to know the number of roots in a given quadratic equation. A. In the first equation, we have a, 1 is equal to 1, b equals 3 and c equals 8. Thus, we have the following as shown on screen. Since the discriminant is negative, this quadratic equation has no solutions. B. In the second equation, we have a, equals 5, b equals -1 and c equals -4. Thus, we have the following as shown on screen. Since the discriminant is positive, this quadratic equation has two distinct solutions. C. In the third equation, we have a, equals 1, b equals -10 and c equals 25. Thus, we have the following as shown on screen. Since the discriminant is 0, this quadratic equation has one solution, two equal roots. D. We can obtain useful information about the original equation quadratic equation by studying the discriminant. Let's consider an example to clarify this point. Example 2. The quadratic equation x squared minus mx plus 9 is equal to 0 has two equal roots. What are the values of m? Solution 2. From theory it is known that when a quadratic equation has two equal roots, otherwise we say it has a single root, then its discriminant is 0. We have a equals 1, b equals minus m and c equals 9. Hence, from the formula of discriminant alpha, we have the following as shown on screen. That is all for lesson 9.6.2. To continue this tutorial, please watch 9.6.3, Quadratic Equations in Practice. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.